I'm Michael Walker again, and I'm going to talk about 5 Walker data science laws. I've been leading data science teams for years, and I've come up with 5 laws that I have distilled. This is a very brief synopsis of a piece that's going to appear in the International Journal of Data Science. So the first law is organizations with the best quality and variety of data, machine learning, and algorithms will win in the long term. What do I mean by that? What I mean is that decisions made by high-performance computing, machine learning, and algorithms will usually be better than decisions made by just humans alone. On the other hand, data science evidence in conjunction with human creativity is going to be superior to just algorithms and machine learning alone. So there have been many experiments and evidence that bears this out, the most famous one being chess. A human plus a computer playing just a computer almost always beats the computer. A human and a computer playing just a human almost always just beats the human. And this runs counter to the media narrative, which is machine versus human. And I would like to suggest to you that that's not the case at all. In my experience, the winning organizations are partnering humans and machines to make better decisions. So, data scientists need to team with data engineers, and it's been my experience that great data scientists will produce really bad work if they don't have a really good data engineer, and vice versa. A great data engineer can have a very bad data scientist, and they're going to produce bad work. So it's really a total team effort. Data science is a team sport. Also, human bias, unethical behavior, bad laws can impede or totally erase any advantage that you're going to get from data science. A big one in the big data hype today is that you're going to get all these incredible insights and be able to make accurate predictions from big data, large data sets. Actually, in my experience, that's not true. Now, there are a few cases where big data can add huge amounts of value, but I would argue there are very few cases where that is the case. And in fact, you're going to more consistently get insights and advantage from data variety and data integration. So the second law is the life of data science is experience and not models, statistics, math, logic, or elegant computer code. So what do I mean by that? Well, the goal of data science is to add value. It's to find truths that nobody else knows. It's to come up with different ways to think about things. It's about helping people in any organization make the best possible decision that they can make. Now, models, statistics, math, coding, they're all important, but they're tools. And the technology out there is very, very important, but again, they're tools. And data scientists need to select the right technology with the right technique for the right job. So I've also found that the best data scientists are very creative. They're contrarian thinkers. They think very differently, and they're able to be mentally agile. They don't get stuck on something. They're able to take one subject and look at it 15, 16 different ways from different angles. They're very skeptical. They're always questioning assumptions. They're always questioning processes and engaging in what-if analysis. So people often ask me, well, what the heck do data scientists really do? Do they sit and they build models all day? And I said, no, they may build models that can be useful, but really most data scientists are designing and executing experiments. Most of them are designing and executing machine learning algorithms. Most of them are trying to figure out how to select and collect the right data that's going to provide advantages in designing processes to collect needed data that isn't currently available. I get this all the time. A lot of organizations really need very specific data sets to make better decisions, and it's just not out there. With all the data out there, they can't find the data that they really need, and data scientists need to go out and figure out a way to collect that data. And it sounds easy. It's actually very, very difficult. So data science is a team sport. A lot of people think there's this superhuman data scientist that's an expert in math, coding, statistics. It's just not true. These individuals are very, very rare, and therefore data scientists really specialize. They're usually good in 1, 2, maximum 3 areas. Usually they'll specialize and be an expert in one area. The biggest thing or skill that a data scientist needs to have, I think, is deep analytical and creative thinking, along with really good communication skills. Because if you can't communicate your results to the decision makers, you've added no value, no matter how great your work is. So communication skills are really important. So the third law: data science shall honor the scientific method or lose credibility. And I think this is really, really important. Again, the scientific method, in addition to deep analytical and creative thinking, is really what separates data scientists from your garden variety data analysts or your business analysts. If we don't honor the scientific method, if we don't use critical and creative analytical thinking skills, we're not really doing data science. So the other thing I think is a misapprehension among the public. People think that data scientists can do forecasting and predict. And we do that. We do that in the finance area with hedge funds. We help an economist do that, for organizations trying to predict supply and demand curves. But really, it's an inexact science, especially in high causal density areas, especially when you're dealing with human behavior. And there are a lot of variables that you just cannot predict. Things just surprise you or come out of nowhere. So I would suggest that we need to really tell our clients, tell our employers, we can't really give you an accurate prediction, but what we can do is we can look at the data and give you several scenarios, and then we can give you probabilities with error bars, okay? And then you can make the decision. We're not going to make the decision for you, but we can give you these different options and give you the probabilities. So we have to get the public to start thinking in terms of probabilities. And I know it's easy for me to say this. In practice, it's very, very difficult to get human beings to start thinking in probabilities. So one of the things I'm really concerned about is the current infatuation with people collecting huge amounts of data and looking at patterns and finding correlations. I think it's very dangerous, although it can be useful and you can find value in it. We all know correlation doesn't equal causation, but humans have a flaw, and I think it's a built-in evolutionary flaw. We tend to interpret meaning in patterns that really isn't there. I know I do it. I can sit and look at clouds and say, wow, doesn't it look like this, that, and the other thing. And I see this all the time, even among trained, experienced data scientists, looking at patterns and interpreting some sort of meaning. It's not there. And folks, I'm going to be honest with you. Most things in life are random. You can see all sorts of patterns, there's all sorts of correlations, but in truth, it's really random, and we need to be very careful not to mistake noise for signal. Another concern that I have is cherry picking of data. I see this all the time. Data scientists have an hypothesis, they want to believe in something, and they'll cherry pick data that confirms their hypothesis or what they believe in, and they'll ignore all sorts of contradictory evidence. I see this every day. It's very dangerous. We need to be on the lookout, and I think we need in our teams to create checks and balances to make sure, because sometimes this happens subconsciously. people aren't even aware that they're doing it. Look, if you can pick whatever data you want, you can basically dictate the results. And I think that that's happening in a lot of academia. I think there was a study by John Ioannidis of Stanford University that showed that over 90% of medical research papers cannot be replicated. And if you really dig into it, he found all sorts of cherry picking of data and confirmation bias, it's something we really need to be careful about. So the fourth law is organizations that run the most low cost and low risk experiments gain competitive advantage. This is really, really important because a lot of what people think data scientists do is use math and statistics and create models all day. And we can create models, and they're very, very useful. They can be very, very valuable. But in reality, what you need to do, and this takes leadership from the top, whether it's in a government organization or a corporation, to run experiments, let people fail. And the way you do this is you reduce or you mitigate your risks. You run a very, very small scale, and you need the data scientists there to collect the data, and again, use scientific methods and deep analytical thinking to think about what this experiment is really, really saying. I'll give you an example, 2 examples. Google runs millions of experiments. Google's basically gotten out of model land. They don't do models anymore. They run experiments. And low risk, low cost experiments, and 98% of the time, these experiments wield nothing. It fails, but 2% of the time, they find incredible insights. They find company groundbreaking new strategies, and then they're able to slowly scale them up. That's what makes them so successful. The successful hedge funds that I work with all do experiments. They run very low cost, low risk experiments, find out what works, what doesn't work, and sometimes what works at very low scale, actually once you start to scale it up, doesn't work anymore. So you need to be very careful about it. But those businesses that run the most experiments and do it in a scientific method will win in the long term. They will outperform those organizations that don't experiment or just try and do predictive modeling. So the last data science law, models should be judged by reasonable, duteous, or untestable assumptions, not only predictive results. What do I mean by this? All models are an illusion of reality. So, and oftentimes people come to me with these beautiful models, and I ask, well, what are your assumptions in the models? And they hem and they haw, they huff and they puff, but when you really look at the assumptions, they're horrible. The assumptions are unreasonable, they're very speculative, they're untestable, and most of the time it looks like they actually pick the assumptions to achieve a certain result. So I'm going to argue with you, when you look at a model, it's not just the predictive result that you look at. You need to really look at the assumptions. Bad assumptions have consequences. If you have unreasonable assumptions, you're going to create bad results, even if you get good predictive results from the model for a certain period of time. But remember, even a broken clock is right twice a day. So what do we get from this? Well, data scientists should use models properly to gain understanding when no real alternatives are available. And I strongly suggest that we build simplified models with reasonable, testable assumptions that capture what's important, and then subject both the assumptions and the results to rigorous empirical tests. Thank you very much.